Alright, so in this lesson we are going to talk about adding fractions. Adding fractions is not that difficult, but just like ordering fractions, it does take a little bit longer in terms of process. Just like when we talked about multiplying and dividing fractions, I'm going to show you all the different scenarios today. So make sure that you refer back to this video if you need it. And then also your guided notes are a great place to go back. They should be organized really well with the different situations. So today you're going to learn how to add fractions with like denominators and with unlike denominators. All right, so let's first talk about the easiest example. So fractions with like denominators. That means denominators that are the same. So bottoms that are the same. So the first thing that we're going to do is we're going to add the numerators together. So 3 plus 4 is 7. The second thing we're going to do is we're going to keep the denominator the same. So we're just going to bring it over. And if needed, we are going to simplify. In this case right here, we do not need to simplify, so we are done. Let's go ahead and do a couple of those examples. So step 1, we're going to add the tops together. So 11 plus 7 is 18. Step 2, we're going to bring the denominator over. This can simplify. The GCF here is going to be 6. So I'm going to divide the top by 6 and I'm going to divide the bottom by 6. Okay, and that's going to give me 3 over 2. And I can leave it like that, but just to practice, I'm also going to make it a mixed number. 2 goes into 3 one time, and then the difference between 2 and 3 is 1, and I leave the bottom the same, so 1 and 1/2. All right, example number 2, so I'm going to add the tops together. 1 plus 4 is 5, and I'm just going to bring the bottom denominator over. And 5 over 11 cannot be simplified, so I am done. All right, example number 3, I'm going to add the tops together. So 15 plus 11 is going to be 26. And bring the bottom over, which is 26, and that is going to simplify to 1 whole. And so 1 whole number is going to be your answer. All right, example number 4. So I'm going to add the tops together. 5 plus 5 is 10. And I'm going to keep the denominator the same. I'm just going to bring it over. This does need to be simplified. My GCF is 2. So I'm going to divide the top by 2. And I'm going to divide the bottom by 2. 10 divided by 2 is 5. And 6 divided by 2 is 3. You could leave this as your answer, or also make it a mixed number. 3 goes into 5 one time for 3. The difference between 3 and 5 is 2, and I leave the bottom the same. Okay? All right, now let's take a look at what happens when the bottoms are not the same. So this is where it gets just a little bit more complicated. So the first thing I'm going to do is, just like when I was ordering the fractions, I'm going to find the LCM of the denominators, and I'm going to rewrite an equivalent fraction of the denominators. This should not be totally new to you because this is exactly what we did when we were ordering the fractions. Then I'm going to follow the exact same rules I just did for like denominators. I'm going to add the numerators together, keep the denominator the same, and simplify. So let's take a look at what that'll look like. So here I have 3 over 4 and 1 over 3. What's the LCM of 4 and 3? It's 12. So how many times does 4 go into 12? 3 times. So 3 times 3 is 9. So I made a new fraction here, 9 over 12. It is equivalent to 3 over 4. Why? Because I multiplied the top times 3 and the bottom times 3. How many times does 3 go into 12? 4 times. So what I did is 3 times 4 to get 12, and I have to do the same thing to the top. 1 times 4 to get 4. Okay? So I have 2 new fractions down here. Now I have common denominator. So I add the tops together, I get 13, and I just drag the bottom over. So this is 13 over 12, or 1 and 1/12. All right, let's do some examples here. So here we have bottoms of 6 and 9. And so what would the LCM of 6 and 9 be? What's the smallest multiple that they would have in common? Okay, and that would be 18. Okay, so how many times does 6 go into 18? 3 times. So what's 1 times 3? 3. How many times does 9 go into 18? 2 times. So 2 times 2 is 4. Now I have like denominators. So 3 plus 4 is 7, and I just drag that bottom over for 18. And I do not even have to simplify because it's already as simplified as it can go. All right, so here I have a denominator of 8 and 3. I have 7 over 8 plus 2/3. Okay, so what would be the LCM of 8 and 3? So I have 8 and I have 16. 3 doesn't go into 8 or 16, but it does go into 24. So 24 would be the LCM. So how many times does 8 go into 24? 3 times. So whatever I do to the top, I do to the bottom. 7 times 3 is 21. How many times does 3 go into 24? 8 times. Whatever I do to the top, I do to the bottom. Remember, that's part of that equivalent fraction. So 2 times 8 is 16. Now I'm going to add the tops together. 21 plus 16 is going to be 37 over 24. And that's as simplified as it goes because 37 is prime, but we can also make it a mixed number. So 24 goes into 37 one time. What's the difference between the two of them? It's going to be 13 over 24. All right, let's look at another example. So here we have 6 and 8. Okay, so we have 8, and then we have 16, so they still don't match, and then we have, after 16, we have 24, so they both go into 24, so 24 is the LCM. Okay, so 6 goes into 24 4 times, so 5 times 4 is 20. 8 goes into 24 3 times, so 3 times 3 is 9. All right, now we add them up. 20 plus 9 is 29 over 24. And that's as simplified as it goes, but we're also going to make it a mixed number. 24 goes into 29 one time, and the difference between the two of them is 5, and we keep the same bottom. Okay. All right, now mixed numbers. I actually find them to be a lot of fun. I use something called a WF chart, and I think that it makes them very easy. So when you have mixed numbers, I always recommend using a WF chart. And what you do is you make a chart just like this. It's called the T chart because it looks like a big lowercase t. And you put a W on one side and it stands for whole number. And you put an F on the other side and it stands for fraction. And then here's your problem. 3 2/5 plus 6 1/5. And all you do is you pick it apart. So you take apart the whole numbers, so 3 and 6, and you add them up on this side. 3 plus 6 is 9, and you're done with your whole numbers. Then you have your fractions. So you have 2/5 plus 1/5 equals 3/5. And so you're done with that. Now you put them together. 9 and 3/5. And so your answer is 9 and 3/5. So a WF chart makes it very, very simple. Now, if you don't have a common denominator over here, that's okay. You just find it, but again, you just add it back to that whole number at the end. So let's go ahead and practice a little bit of that real quick. So I'm going to make myself a WF chart. Oops, that's not a straight line. Okay, so I'm going to take my whole numbers here. So 3 plus 2 is 5. And then I'm going to take my fractions. So I have 1/9 plus 2/9. That's 3/9. Now 3/9 can be simplified to 1/3. Okay, now I just put it together. So my answer is 5. Here's the whole number. Here's the fraction. And 1/3. And we're done. Let's try another example. So I'm going to make my WF chart. And remember, W just stands for whole number, and F just stands for fraction. Okay, so here's my whole number. And if you want a color code, that's fine with me. So 4 plus 1 is 5. And then here's my fraction. So I have 4/5, and this is going to be another good example of a different situation. So here we have the same denominator, but we have 4 plus 3, so that's 7/5. Now, if I took these two together, I would end up with 5 and 7/5. That does not make sense, because this 7/5, we know that improper fractions are greater than 1. So all I have to do is take this 7/5 and make it a mixed number, which is 1 and 2/5. Okay? And now I just add it to the 5. So what's 5? A whole 5 plus a whole 1? 6, and then 2/5. And that's it. All right, let's look at another example. Don't let it scare you. It's just lined up a little bit differently. Just trying to show you a bunch of different formats that you might encounter. So I'm going to make my WF chart. Okay, here's my whole number. So I have 4 plus 2, and that's 6. All right. And this time I do not have common denominators, so I have 5/6 plus 2/9. So what is my LCM? 18. Okay. So now, how many times does 6 go into 18? 3. 5 times 3 is 15. How many times does 9 go into 18? 2. 2 times 2 is 4. Okay? So 15 plus 4 is 19, and I scoot that 18 right over. Now I have that same situation I just had before. 19/18 is an improper fraction, so I can't marry it with the 6 yet. So let's make it a mixed number. 18 goes into 19 one time. Okay? What's the difference between the two of them? 1, and I keep the same bottom. Now I can marry them. Whole number 6, whole number 1 for 7, and my fraction is 1/18. All right, let's take a look at this guy here. WF chart. Here's my whole number. So I have 3 plus 2 is 5. Here's my fraction, and it looks like I do have a common denominator. Okay, 6 plus 4 is 10/10. 10/10 is 1. So when I marry these two guys together, 5 plus 1 is 6. That worked out really well. All right, let's try this guy here. Make my WF chart. Oops, I wanted to do that in black. The WF chart is just very helpful in terms of organizing information. Here's a 2, here's a 1. 2 plus 1 is 3. Now I'm going to grab my fractions. Here's 2 over 3 plus 3 over 4. So I do not have common denominators. Okay, so what's my common denominator for 3 and 4? It's going to be 12. My LCM is 12. Now, how many times does 3 go into 12? 4. So 2 times 4 is 8. How many times does 4 go into 12? 3 times. So 3 times 3 is 9. So let's bring it all across. 8 plus 9 is 17 over 12. Now remember, because this is an improper fraction, I can't marry it with the whole number yet. So 17 over 12, I need to make it into a mixed number. 12 goes into 17 one time. What's the difference between the two of them? 5, and I keep my same bottom. Now I can marry the two of them together. Whole number 3 plus whole number 1 is 4, and then I keep that fraction 5 over 12. All right, you go ahead and try these two, and then we'll review the answers. All right, you can go ahead and pause if you're not done, but if you are done, let's go over them. So for the first, well, for both of them, they had unlike denominators. So for the first one, they had a common denominator of 18. So I got 17 over 18. For the second one, they had a common denominator of 34. And so the answer was 29 over 34. All right. Oops, did not mean to do that. All right, go ahead and try these two. All right, go ahead and pause if you're not done, and if you are, let's go ahead and discuss. So for the first one, the numbers got just a little bit big, but nothing you couldn't handle. So the common denominator between 5 and 11 was 55. When you added it up, you should have gotten 79 over 55, which cannot simplify, which you could have left as 79 over 55, or a mixed number of 1 and 24 over 55. The second example did already have a like denominator, so it was 11 over 8 or 1 and 3 over 11. Okay, go ahead and try this one. All right, go ahead and hit pause if you're not done, and if you are, let's discuss. So when we made our WF chart, we got 13 as our whole number. We had to find a common denominator, which was 15, and we ended up with 22 over 15, which we had to turn into a mixed number, 1 and 7 over 15. And when we added it back to the 13, we got 14 over 15. All right, go ahead and try this one. All right, you can go ahead and pause if you're not done. So for this one, when we added up the whole numbers, we got 12. And then when we did the fractions, we had a common denominator of 24. And we got 18 over 24, which we simplified down to 3/4. So we ended up with 12 and 3/4. All right, that is the end of adding fractions. It's not too bad. You just need to remember the rules for finding your common denominator and remember to use your WF chart for adding mixed numbers.